On a crisp fall morning last October, King Middle School in Portland, Maine, invited 8th graders to what it calls a kickoff, the unveiling of an in-depth project that would be at the center of nearly all the students' courses for the next 4 months.
So I direct your attention to this slide. This is called Earth at Night.
Science teacher Peter Hill set the stage.
There are certain parts of the world that use a ton of energy. Along with that, 25% of the world's population doesn't have electricity in their home. But enough solar energy hits the Earth every hour to supply the entire world's energy needs for a year. So we need to design tools that can capture all that sunlight that's hitting our Earth, or capture all that wind power that's sitting out in the Gulf of Maine. We need to, wait for it, revolt.
Hill handed the students an ambitious assignment to fulfill by the end of the project.
You're going to create a device that captures natural energy and transforms it into something that's useful for people in some part of the world.
I was like, I can't do that.
Taking all this in was Leva Pierce.
That's way too much. I don't know the first thing about electricity. I don't know the first thing about windmills. I am totally gonna fail.
This expedition began with a design challenge.
We're building robots that are made to collect resources, which are ping pong balls.
Nat Youngren and his classmates were building their robots from kits that allow for an almost infinite number of possibilities.
You can do whatever you want to make them do this, but they have to be able to go out, get ping pong balls, and bring them back. I made mine completely sound controlled, so you can control it to turn and move back to your base.
This one has to be much longer.
Working in teams, students spent 4 weeks perfecting their robots in a class called Tech Ed. Gus Goodwin is the teacher.
This kind of really hones in on engineering. What is the design process?
I'll take care of the programming, but if you just...
They have to program a robot, build it, tinker with it, and get it to work.
Leva Pierce, who at the kickoff had feared failing, seemed to embrace robotics.
We made this wide thing that when it goes forward, it will catch the balls. It's pretty hard.
Two! We got two! Let's go, chipmunks, let's go! Let's go, chipmunks, let's go!
Just before Thanksgiving, students put their creations to the test at a school competition dubbed Robo-Wars.
Get set, go!
Nat Youngren's robot started well enough and stalled. The room was too noisy for its sound controls.
Oh my God.
As for Leva Pierce, her team finished second. The objective for all the students was that this activity would somehow bring them closer to designing an energy-generating device of their own.
The robot competition was really successful.
Kids are really, I think they've internalized the design process. They know it's an ongoing process. They know they need to engineer their designs and constantly revise and get feedback, and so we're on our way.
By early December, students were on to the second leg of their journey, learning the science and social issues that would be at the heart of their invention. And the path teachers chose to take students there, an 8-week-long interdisciplinary study of wind power. Science teacher Peter Hill.
We started with a wind turbine. How do these things create electricity? And we took apart a motor. And we said, well, there's magnets and wires in here. How do magnets and wires interact to generate electricity?
To make the learning go deeper, in Tech Ed class, students built working model wind turbines.
The criteria for this project is a wind turbine that is stable and sturdy. It has to generate at least 1 volt of electricity. And the other piece is we want it to be creative, outrageous, ingenious, and inspirational.
The politics of wind power was the subject in social studies. Emma Schwartz.
The point is to find a place where it would be good or possible to have a wind turbine see what the environmental impacts might be if there's a bunch of huge turbines in the area.
You get those discussions around what is the sense of place and what is scenic beauty and how do you alleviate that issue.
Let's see where you are.
Next, Mark Jervis's students will argue for their turbine in a persuasive essay addressed to local officials. But for their life-improving invention, students would need to know about faraway places. In English class, they read The Boy Who Harnessed the Wind, the autobiography of William Kamkwamba of Malawi, Africa.
He managed to build a big wind turbine, power his house, and he did it all with a book and some trash.
They went through this awful famine, and that was really, really shocking to me that he can go through that and still have hope.
I think that was a really big theme in the book. If you really just try and you don't really stop, no matter what's in your way, you'll eventually get there.
Inspired by the book, students like Leva Pierce pushed ahead with their own model wind turbines.
I had a lot of struggles with my turbine. And I said, you know what? I'm gonna make this generate more than a volt. So I made a whole new set of blades. That worked a lot better. But then I heard about other people that were getting oh, I heard he got 6 volts. And I was like, oh, gotta get more than that.
After 8 weeks and 3 new sets of blades, Leva and her classmates' wind turbines were finally ready. And King Middle School staged another competition.
The more I got into it, the more I just couldn't stop. I was steadily increasing, which is really, really good.
Each turbine's electrical output was captured by a computer. Leva's topped out at 5.9 volts. For the final event of the project, parents were invited in to hear all about the students' inventions.
The rub-a-dub scrub takes the usually wasted rotational kinetic energy of... This is live, you're showing what you're learning to other people, which kind of gives you something more back, I think.
And you have to be clear and concise. Giving presentations is so important because it really arms you with skills that you'll need later in life.
Just think if washing dishes could be fun.
Like Emma's invention, the students' creations will go no further than the drawing board. What's more, as they move on to new subjects and new grades, they may forget the particulars of amps and electrons. But some things they will remember.
Through this expedition, I have learned how to communicate with other people to make something happen. And I think that's what changed me most.
Before this expedition, I kind of always thought of myself as I'm good at writing and I'm good at reading, and that's what I'm good at. This expedition has completely changed my idea of science. Science is doing, and science is building, and science is creating.
What makes this school a success? It's not because of any charter status. It's a regular public school. It's not because it caters to some students over others. It's diverse, with open admission. The secret, as we saw it, was relevance.
Usually in school, you learn about things that are happening in the world that are bad. In social studies, you might learn about an earthquake. But I feel that schools shouldn't just be about learning about problems. I think they should be about solving them. Because if you aren't learning about how to solve problems, then what will you do when you're out of school?